They will tell you the universe has no edge. They will tell you it stretches on without end, that the question itself is broken, that asking what waits at the edge of space is like asking what lies north of the North Pole. A meaningless question, a child's question, something you grow out of, but that's not the whole truth. And tonight, in the quiet, we are going to sit with the part they leave out. Because there is an edge. You have one right now, a real boundary hanging in every direction around you, and it is closer than you think and stranger than you were told. We can see it. We have photographed it. It has a temperature, a precise one, measured to a fraction of a degree, and in a few places along that boundary, the numbers do something they are not supposed to do. They go cold where they should be smooth. They lean in one direction when they should point nowhere at all. Whole rivers of galaxies drift toward a spot in the sky that we cannot explain, as if something on the far side of the wall is pulling, patient and enormous and out of reach. Tonight we are going to walk all the way out to that wall. We are going to pass through every serious theory about what is hiding at the edge of space, and starting with the things we know for certain, and ending in the places where even the most careful scientists go quiet. We will pass the wall of light. We will stand in front of the cold patch that might be a bruise. We will feel the pull of the dark flow. And by the time we reach the last edge, the one made not of distance but of time, you may find that the question you grew out of was the most important one you ever asked. So settle in, let your shoulders drop. There is nowhere to be and nothing to solve. Just let the voice carry you outward, slowly, past the last star you can name and into the dark beyond it. If drifting out to the edge of everything sounds like a good way to fall asleep tonight, go ahead and hit that like button and subscribe, so the quiet keeps coming night after night, and you never run out of dark to fall into. And before you close your eyes, leave a comment and tell me where you are listening from, and what time it is there, because somewhere out at the edge of someone else's sky, you are the distant light they will never reach. Part 1. The edge that isn't there. Start with something simple. Stand on a beach at night and look out across the water. There is a line out there, far away, where the sea seems to stop and the sky begins, the horizon. You can see it clearly. You could point at it, but you could also walk toward it for the rest of your life and never arrive, because the horizon is not a place. It is not a wall sitting at the edge of the ocean. It is just the distance at which the curve of the earth hides everything beyond it from your eyes. The horizon belongs to you. Move 10 steps to the left, and it moves with you. Someone standing on a beach 1,000 miles away has a horizon of their own, and the two of you will never share the same edge. The edge of the universe is exactly this kind of edge, and once you understand that, the whole picture changes. We call it the observable universe. It is the part of the cosmos we are able to see, and it has a definite size, a real number you can hold in your mind. But the reason it has an edge is not because matter runs out. It is because light is fast, but it is not infinitely fast. Light takes time to travel, and the universe has only existed for a finite stretch of time, about 13.8 billion years, give or take. So the only light that has reached us so far is the light that started its journey close enough to arrive within that window. Anything farther away than that, the light is still on its way. It has not gotten here yet. It may never get here. That distance, the farthest that any signal could possibly have travelled to reach us, is our cosmic horizon, the edge of what we can see. Now here is the first strange thing, and I want you to let it settle slowly, the way you would let warmth settle into your hands. You might assume that if the universe is 13.8 billion years old, then the edge of what we can see must sit 13.8 billion light years away. Light has had that long to travel, so that should be the limit. It is a reasonable thought. It is also wrong, and the reason it is wrong is one of the quietest, deepest facts in all of science. Space itself is stretching. It has been stretching the entire time that light has been travelling through it. So a beam of light that set out toward us in the early universe was not crossing a fixed distance. The ground beneath it, if you can call empty space a kind of ground, was expanding the whole way, carrying its starting point farther and farther behind it even as the light pressed forward. By the time that ancient light finally reaches your eye tonight, the place it came from has been swept much, much farther away than 13.8 billion light years. How far? The number is about 46 billion light years, in every direction. The edge of the observable universe sits roughly 46 billion light years away on all sides, which means the whole visible sphere, from one side to the other, stretches something like 93 billion light years across. 93 billion. A bubble of seeable cosmos so vast that the word vast stops meaning anything at all. And inside that bubble, there is everything you have ever heard of, and almost everything you will ever wonder about. Every star, every planet, every galaxy that telescopes have ever caught. Estimates of how many galaxies fill that sphere have run as high as 2 trillion. 2 trillion galaxies, each one a city of 100 billion suns or more, each sun a chance for worlds, and all of it packed inside a single sphere of light centered, as far as you can tell, on you. That is the part that catches in the throat if you let it. The observable universe is centered on the observer, on you. You are sitting at the exact middle of your own private sphere of visible cosmos, and the edge is the same distance from you in every direction, because the edge is defined by how long light has had to reach the spot where you happen to be. Walk to the other side of the planet and you carry the center with you. Travel to a galaxy 1 billion light years away, and the center goes too. There is a sphere of seeable universe around every point in space, and no two of them line up perfectly, which means the edge is not out there in some fixed location, waiting to be visited. The edge is a relationship between you and the speed of light and the age of time. It is your horizon. It belongs to you the way the line on the ocean belongs to you. And just as someone on a distant beach has their own horizon, a creature on a planet near the edge of your sphere has its own sphere, reaching billions of light years past anything you will ever see, into regions you have no access to and never will. Sit with that for a moment, because it leads somewhere tender. If that creature looked back toward where you are, toward the faint smudge of light that is the Milky Way as it appeared billions of years ago, you would be sitting at the edge of its universe. You would be the distant glow on its horizon, the thing it can almost see and can never reach. To something out there, you are the edge of space. You are the mystery at the boundary. You are the unreachable light. Now you might be waiting for the obvious question, and it is the right one to ask: what is past it? If the edge is just a horizon, just the limit of how far light has travelled, then surely there is more universe out there beyond it. Surely the galaxies do not simply stop at 93 billion light years like a painting that ran out of canvas. And the honest answer, the one the careful scientists will give you, is that almost certainly there is more, far more. The edge of the observable universe is not the edge of the universe. It is only the edge of the part we can witness. Beyond it, the best evidence suggests space keeps going, filled with more galaxies, more stars, more of the same quiet machinery stretching out past our horizon to a size we cannot measure and may never know. How much more? That is where it gets dizzying, and we will come back to it, because the answer might be that there is no more, not in the sense of running out, in the sense that it never ends at all, but for now, hold on to the smaller, stranger truth, the one we are sure of. The edge of space, the one you can point to, the one telescopes run up against, is not a wall and not a barrier and not the end of anything. It is a horizon. It is the shoreline of your own seeing, and it is moving. Because the universe keeps expanding and time keeps passing, light from farther and farther away keeps having just enough time to reach us. So the horizon grows. Every year, the edge of the observable universe creeps outward by roughly 1 light year, as the light from ever more distant regions finally completes its journey and arrives. Slowly, almost imperceptibly, your sphere of seeable cosmos is getting larger as you lie here. The edge is not fixed, it breathes. And yet, for all of that motion, there is one thing waiting at the very limit of your sphere that does not move and does not change and has been sitting there since before the first star. The oldest light there is, a wall of a kind at the far edge of everything you can see, and it is glowing. Part 2. The Wall of Fire. When you look out into space, you are looking back in time. There is no way around this, and it is one of the most beautiful facts we have. The light from the moon you see tonight left it just over a second ago. The sunlight on a morning window is 8 minutes old. The nearest stars you can name with the naked eye are showing you years and centuries into their past. Look at the Andromeda galaxy, faint and smudged, and you are seeing light that left it around 2.5 million years ago, before your species had a name. The farther out you look, the deeper into the past you fall. Distance is time. To gaze at the edge of space is to gaze at the beginning of it. So follow that thought all the way out. Keep looking farther, which means keep looking earlier, past the galaxies, past the first galaxies, the dim red infants that the largest telescopes strain to catch. Keep going, back toward the very young universe, when everything that exists was crammed into a space unimaginably hot and dense and bright. What would you see at the very edge, at the very beginning? you would see a wall of light, and it has been waiting at the edge of every observer's universe since the cosmos was a newborn. In the first few 100,000 years after the beginning, the universe was not transparent. It was a fog. Not a fog of water, but a fog of raw matter, so hot that atoms could not even form. Electrons and protons flew free, unbound, a roiling plasma, and light could not travel through it. Every time a particle of light tried to move, it slammed into a free electron and scattered, like sunlight lost inside a thick cloud. The whole universe glowed, and yet it was opaque, a furnace with no outside, light trapped everywhere and going nowhere. Then, about 380,000 years in, the universe cooled enough to cross a threshold. It dropped to a temperature around 3,000 degrees, cool enough at last for the electrons and protons to settle together and form the first stable atoms, and in that moment, almost all at once across the entire cosmos, the fog lifted. The free electrons that had been scattering the light vanished into atoms, and suddenly light could fly. For the first time, the universe became transparent, and all the light that had been trapped inside the fog was set free to travel. That light is still travelling, right now, tonight. It has been crossing space for more than 13 billion years, and a tiny fraction of it is arriving at the Earth at this very second, falling on the rooftops and the oceans and the backs of your closed eyelids. We call it the cosmic microwave background, and it is the oldest light in existence. It is a photograph of the universe at 380,000 years old, the baby picture of everything, taken at the instant the fog cleared. And here is why it stands at the edge. When you look out toward that ancient light, you are looking at the moment the universe became see-through. You cannot see past it, because past it, deeper in time, the universe was opaque. There is nothing to see beyond the wall of fire, not because space ends there, but because light could not escape from anything earlier. The cosmic microwave background is a curtain of last light, the surface beyond which the cosmos goes dark to us, not because it is empty, but because it was blind. Scientists call it the surface of last scattering, the last place the light bounced before it broke free and came to find you. So the true edge of what any of us can ever see is not a galaxy and not a star. It is this. A sphere of ancient light surrounding us in every direction, the glow of the infant universe arriving from the limit of time itself. A wall of fire at the edge of space, except the fire has cooled. This is the gentle part, the part that helps the whole thing make sense. That light was born at 3,000 degrees, blazing, the colour of a furnace. But it has been travelling through expanding space for over 13 billion years, and all that while, space has been stretching, and the stretching of space stretches the light along with it. A wave of light pulled across an expanding universe gets longer and longer, sliding down from the searing white of the early cosmos, through red, past the edge of what eyes can see, down into the long, slow ripples we call microwaves. By the time it reaches us, that furnace glow has cooled all the way down to less than 3 degrees above absolute zero. The hottest moment we can witness has become the coldest whisper in the sky. You cannot see it with your eyes, but it is genuinely everywhere. It's coming through the walls around you right now, soaking through your body, raining in from every direction at once, the faint and patient heat of creation. Before we understood what it was, we found it by accident, as a hiss of static that radio engineers could not get rid of, a noise that came from no transmitter and pointed at no source, the same from every part of the sky, the leftover warmth of the beginning mistaken for interference. And once we knew to look, we built machines to map it. Spacecraft lifted above the atmosphere to read the temperature of that ancient light across the entire sky, degree by degree with almost unbelievable precision. First a probe that gave us the rough portrait, then sharper eyes, mapping the wall of fire down to its faintest textures. What they found is the thing that makes cosmologists fall silent. The wall is almost perfectly smooth. Look anywhere on that sphere of ancient light, and the temperature is the same to a staggering degree. From one side of the sky to the other, the glow of the early universe matches itself to about 1 part in 100,000. Imagine an ocean stretching across the whole world, and the highest wave anywhere on it rising no more than the width of a hair. That is how even the early universe was. That is how gentle the beginning looks. That smoothness is a gift and a puzzle at the same time. It is a gift because the tiny imperfections in it, the faint warm patches and cool patches 100,000 times subtler than the whole, are the seeds. Those whispers of difference are where matter would later gather, where gravity would pull, where the first stars and galaxies, and eventually you would slowly grow. The entire structured universe, every galaxy in that 93 billion light-year sphere, was written into the wall of fire as the faintest texture, the gentlest unevenness in an almost perfect glow. We can look at the baby picture and find already drawn in light the outline of everything that would ever be. But it is a puzzle too, and the puzzle is the doorway to everything that comes next on this long walk to the edge. Because the wall is too smooth, far too smooth. Opposite sides of that sphere, the patch of ancient sky in one direction and the patch in the exact opposite direction are the same temperature to that incredible precision, and they should not be. Those two regions are so far apart that in the entire history of the universe, light from one could never have reached the other. They have never been in contact. They have never had a chance to settle to the same temperature, the way a hot cup and a cold room slowly meet in the middle. They are strangers who have never touched, and yet they match perfectly, as if they once shared the same small space and were torn apart before they could ever drift out of step. Hold that contradiction, love, softly as you breathe. The edge of what we can see is a wall of ancient light, smooth beyond reason, carrying the faint seeds of all that exists and matching itself across distances that should have made matching impossible. Something must have happened, very early and very fast, to bring the whole infant universe into that perfect agreement and then fling it apart. Something that stretched a tiny, even patch of cosmos into the enormous, balanced sky we wake up under. And the theory that explains it does not just answer the puzzle of the smooth wall, it opens a door at the edge of space that leads somewhere we may never be able to close. It suggests that our entire 93 billion light-year sphere, the wall of fire and everything inside it, might be a single bubble, one among countless others, and that beyond the edge, past the last light we can ever see, the making of universes might still be going on. That is where we are headed next. But there is no hurry. For now, just rest in the picture of a wall of cooled fire at the edge of the sky, the oldest light there is, falling on you in the dark, smooth as a still ocean, carrying the memory of the morning. Everything began. You are wrapped in it. You always have been. The edge of space is glowing around you, gentle and ancient and warm, and it is the last thing the universe has to show before the dark of the very beginning closes the view. Let it hold you there a while. Part 3. The shape of everything. So something happened, very early and very fast, to take a tiny and even patch of newborn cosmos and stretch it into the enormous balanced sky we live beneath. The leading idea has a plain name for such an extraordinary thing, inflation, and the word undersells it badly because what it describes is the most violent growth spurt that has ever occurred or ever will. In the first sliver of a second after the beginning, far less than a trillionth of a trillionth of a trillionth of a second, the theory says that space did not expand gently. It erupted. A region smaller than a single atom was stretched almost instantly to something larger than a grapefruit, and then far larger than that, doubling and doubling and doubling in size, dozens of times over in a span of time so short that the word instant is generous. By the time it was over, a patch of space too small to see had been blown up to a scale that dwarfs everything we can observe today. And then, just as suddenly, the runaway growth stopped, and the ordinary slow expansion we still live inside took over. This single savage event, if it really happened, explains the puzzle of the smooth wall. The two opposite sides of the sky that match so perfectly, the strangers who never touched, were not always strangers. Before inflation, they were pressed together in that tiny patch, close enough to mingle, close enough to settle to the same temperature. Then inflation tore them apart and flung them to opposite ends of the visible universe, carrying their shared warmth with them. They match because they were once neighbours. Inflation is the story of how the whole sky was, for one impossibly brief moment, a single small room, before the walls blew outward past the horizon. And inflation does something else, something that bears directly on the question of the edge. It flattens things. Let me explain what that means gently, because it sounds abstract and it is not. Space can have a shape, not a shape you could see from outside since there is no outside, but a shape in the way it bends. Imagine drawing a giant triangle across the cosmos and measuring its angles. In the kind of space you learned about in school, flat space, those angles add up to exactly what you expect. And two parallel beams of light stay parallel forever, never meeting, never drifting apart. But space does not have to behave that way. If the universe were curved one way, like the surface of an enormous ball, those parallel beams would slowly bend toward each other, and the triangle's angles would add up to more than they should. Curved the other way, like the surface of a saddle, the beams would spread apart, and the angles would fall short. The universe could be closed and curved back on itself, or open and flaring outward, or perfectly, knife-edge flat. So we measured it. We used that wall of ancient light, the cosmic microwave background, as our giant triangle. The faint warm and cool patches written into it have a known true size, set by the physics of the early universe, and by comparing that true size to how large they appear across the sky, we could read the geometry of all the space the light had crossed to reach us. If space were curved, the patches would look magnified or shrunken in a telltale way, and the answer came back flat within a fraction of a percent. As far as our most careful instruments can tell, the universe is not curved like a ball and not curved like a saddle. It is flat, the way a still sheet of water is flat, across distances of tens of billions of light years. This is exactly what inflation predicts. Take any curved surface and blow it up to a monstrous size, and the small piece you are standing on looks flatter and flatter, the way the curved Earth looks flat to someone standing in a field. Inflation stretched whatever shape the universe started with until our entire visible patch became, for all purposes, perfectly level, but flatness carries a consequence, and here is where it begins to press on the chest. A universe that is flat, truly flat, and not just locally flat, has no reason to close back on itself. A closed, ball-shaped universe is finite. You could, in principle, travel in one direction and eventually come home, the way you can circle the Earth. But a flat universe does not come home. It does not curve back. It just keeps going. And the most natural reading of a flat universe, the simplest thing it could be, is one that is infinite, endless, space without any edge at all, in any direction, forever. Sit very still with that, because it is the strangest thing we have said yet, and it may be true. Not infinite in the loose way people use the word to mean very big, infinite in the exact and merciless sense. More space than any number can count. Beyond your horizon, past the wall of fire, the flat universe may simply continue, galaxy after galaxy after galaxy, with no farthest one, no last light, no boundary anywhere, no matter how far you go or how long you travel. And if that is what the universe is, then something follows that has kept thoughtful people awake in a way few ideas can. In any single patch of space the size of your observable universe, there are only so many ways that matter can be arranged. A staggering number, a number with more zeros than there are atoms in your body, but a finite number all the same. There are only so many ways to place every particle. And if space is truly infinite, then it contains an infinite number of these patches, each one a sphere like yours, each one filled with some arrangement of matter. Infinite patches, a finite number of possible arrangements, which means somewhere out there in the endless flat dark, the arrangements have to repeat. They cannot help it. Every possible cosmos that can exist exists over and over an infinite number of times, including this one, including this room, including you lying here in the quiet listening to a voice describe the edge of space. Unimaginably far away, far past any horizon you will ever have, the same arrangement of particles is playing out again. Another you in another room hearing the same words, and again somewhere else, and again, not as a poem, as a plain consequence of an infinite flat universe and a finite list of ways to build a world. We do not know for certain that space is infinite. Flat is what we measure, but our measurements only cover the part we can see, and a universe that is merely very large would look flat to us too, the way a small enough patch of any curved thing looks straight. Maybe it closes back on itself after a size so vast it dwarfs the visible cosmos. Maybe it ends in some way we have not imagined. But the simplest universe consistent with everything we have measured, the flat and open and endless one, has no edge of space at all. The thing we set out to find may not exist, not because the question was meaningless, but because the answer is too large to hold. And yet inflation, the very thing that flattened our sky, hides one more secret. Because the theory does not just suggest the universe is enormous. In its most natural form, it suggests that the eruption which made our universe was not a single event at all. It suggests it is still happening. Out there, Beyond the wall of fire, the making of universes may never have stopped. Part 4. The Endless Making. Here is the part of inflation that its own discoverers found difficult to accept because once you take the idea seriously, it refuses to stay small. Inflation is driven by a kind of energy woven into space itself, an energy that makes space expand at a furious runaway rate. In our patch of the cosmos, that energy eventually drained away. The runaway growth ended, and the leftover energy poured out as the heat and matter that became our universe. The fire cooled, the galaxies formed, the story we have been telling unfolded. That is how inflation ends. But when cosmologists worked through the mathematics carefully, they found something they had not gone looking for. In most versions of the theory, inflation does not end everywhere at once. It cannot. The inflating energy expands so violently that it creates new inflating space faster than the old inflating space can decay into ordinary universes. Picture a fire that spreads faster than it burns out. Here and there, in scattered spots, the fire dies down and a pocket of calm appears, a region where inflation has stopped and a universe like ours can settle into being. But all around those calm pockets, the inflating space rushes on, making more of itself, opening more room, and within that room, more calm pockets flicker into existence while the space between them keeps inflating without end. This is called eternal inflation, and the name means exactly what it says. Once inflation begins, it may never truly stop. It goes on forever, an endless ocean of furiously expanding space, and within that ocean, universes bubble into being like droplets of calm, each one a region where the storm briefly quieted and let a cosmos take shape. Our entire observable universe, the wall of fire and the 2 trillion galaxies and every theory we have walked through tonight, would be the inside of a single one of those bubbles. One droplet, one pocket of stillness in an ocean that has no shore. And if that is true, then ours is not the only one. It cannot be. The ocean of inflation in this picture has spawned an unending number of bubbles, each its own universe, each surrounded by the same eternal storm forever out of reach of all the others. A multiverse. Not a fantasy invented to be strange, but the natural, almost unavoidable consequence of the same theory that explains the smoothness of our sky and the flatness of our space. The thing that flattened our universe may have made infinitely many others. Now let yourself drift into the part that makes this more than just more space. Because there is no reason to expect the other bubbles to be like ours. When a pocket of inflation calms and a universe condenses out of it, the details of how it settles, the strength of its forces, the masses of its particles, the very rules its matter obeys, may come out differently each time, the way cooling metal can freeze into different patterns depending on how it sets. In one bubble, gravity might be stronger, and everything would collapse into blackness before a single star could shine. In another, the forces that hold atoms together might never click into place, and the universe would be a thin fog of particles, formless forever. In another still, there might be more dimensions of space than the 3 you move through, or fewer, or laws of physics with no echo in anything we know. Most of those universes, if they exist, would be barren, hostile to everything, incapable of stars or chemistry or warmth or anyone to notice. And our bubble, with its patient gravity and its stable atoms and its long, quiet stretches of time in which galaxies could turn and worlds could cool and life could find a foothold, would be one of the rare gentle ones. Not because it was meant to be, just because, out of an endless number of tries, some bubbles come out kind, and only in the kind ones is there anyone awake to ask why. I want to be honest with you here in the dark, because this is exactly the place where the careful science begins to thin out. Eternal inflation and the bubbles it implies are taken seriously by many of the people who understand inflation best. The mathematics points there on its own. But a theory is only as good as the test you can put it to, and this is the trouble. The other bubbles, if they are real, are sealed away behind a wall of inflating space that expands faster than any signal could ever cross. We cannot see them. We cannot reach them. We may never find a single piece of direct evidence that even one of them exists. Some physicists hold that an idea you can never test is not quite science, that it lives in some borderland between physics and philosophy. Others answer that we did not choose this consequence, the theory handed it to us, and we do not get to look away from where the mathematics leads simply because the view is too vast. So we hold it lightly, A possibility, beautiful and unproven, resting at the edge of what we can know. Beyond your horizon, past the wall of fire, an endless storm of inflating space, and in it bubbles without number, universes that will never know each other, ours among them, a single calm drop in an ocean that goes on making worlds forever. But there is a question that even a sealed wall cannot quite silence. If the bubbles are surrounded by inflating space, and that space is endless, then is it truly impossible for one bubble to ever brush against another? And if two bubbles did touch, long ago when ours was very young, would there be any sign? Any mark left on the wall of fire, a bruise from the one-time something on the outside pressed against the inside of our world? Some scientists think there might be, and they think they may have found it. Part 5. The Bruise. For all its impossible smoothness, the wall of ancient light has a flaw, one place where the temperature does something it is not supposed to do. Cosmologists found it when they first mapped the cosmic microwave background in detail, and it has unsettled them quietly ever since. They call it, with no drama at all, the cold spot. It sits in one direction of the sky, a patch about 5 degrees across, which is to say a region of the ancient light roughly the width of 10 full moons laid side by side. And it is cold. Colder than it has any business being. The wall of fire, remember, matches itself across the entire sky to about 1 part in 100,000, an almost perfect evenness. Tiny cool patches and warm patches are expected, the faint seeds of structure, but they are supposed to be small, no more than about a degree across. A cold region this large, this deep, should not be there. On the scale of the cold spot, the universe should look smooth. Instead, there is this, a wide, anomalous chill in the oldest light there is. For years, the favoured explanation was something almost reassuring, a supervoid. The idea is that between us and that patch of ancient light lies a colossal empty region of space, a place where galaxies are unusually sparse, an under-dense bubble hundreds of millions of light-years across. When the ancient light passes through such a vast emptiness on its long journey to us, it can lose a little of its energy, arriving slightly cooled, painting a cold shadow across that part of the sky. In 2015, a study reported finding exactly such a supervoid sitting in the right direction. And for a while it seemed the mystery had a quiet, ordinary answer. A big empty nothing, cooling the light that crossed it. But the answer did not hold. Other teams went looking for the same supervoid and could not confirm it cleanly. Later work, including a careful study led by researchers at Durham, examined the galaxies around the cold spot in detail and found that the void, even if it is there, is not nearly enough to explain how cold and how large the spot really is. The numbers did not add up. The shadow was too deep for the emptiness they could find, and when the comfortable explanation falls away, you are left standing in front of the anomaly with the harder possibilities, the ones the careful scientists mentioned slowly and with many warnings. Because if the cold spot is not a shadow, cast by something between us and the wall, then it may be a feature of the wall itself, a genuinely cold region baked into the early universe. And one of the explanations that has been floated for such a thing, floated cautiously, is the one we have been circling all night. A bruise, the mark left behind from the time another bubble universe collided with ours. Hold this gently because it is as far out as the theories go. In the picture of eternal inflation, our bubble formed in an ocean of inflating space alongside countless others. In the earliest moments, before inflation flung everything apart, it is conceivable that our infant bubble drifted close enough to a neighbouring bubble to touch, the two of them grazing each other like raindrops merging for an instant on a window. Such a collision, the mathematics suggests, would not destroy us. It would leave a signature, a round disc-shaped region pressed into the fabric of our universe, a place where the contact with the other world altered the temperature of the ancient light. A circular cold patch in the cosmic microwave background. A bruise, exactly the kind of thing the cold spot might be. If that were true, then the cold spot would be the single most extraordinary thing humans have ever seen. It would be a fingerprint left by another universe. Direct physical evidence that we are one bubble among many, that the multiverse is not a sealed and untestable dream, but a place that once reached across and touched us, leaving a mark we can still read in the sky 13 billion years later. The edge of space would have a scar, and the scar would be proof that there is an outside. But I promised you honesty, and honesty matters most exactly here, where the temptation to believe is strongest. There is no proof. The scientists who study the cold spot are the first to say so. Ruling out the supervoid does not confirm the bruise. It only removes one ordinary explanation and leaves the door open. The collision idea makes the wildest claim, and wild claims demand evidence far stronger than a single cold patch in one direction of the sky. The cold spot could be a genuine cold region from the early universe with some cause we have not yet imagined. It could even be nothing more than chance, a rare roll of the cosmic dice, an unlikely but not impossible fluctuation that the laws of probability allow once in a great while across a sky this large. Most cosmologists, asked directly, will tell you the bruise is the least likely answer, however much they would love it to be true. And still, the cold spot is there, it is cold and it is large, and the easy explanation has slipped through our fingers, and the door to the most astonishing possibility in all of science remains open just a crack, refusing to close. That is where this one rests tonight. Not as an answer, but as a faint cold mark at the edge of the seeable universe. A place where the wall of fire does something it should not, and where some of the most careful minds alive cannot entirely stop themselves from wondering whether, just once, in the first instant of everything, the outside leaned in. The cold spot, whatever it is, was left behind long ago, frozen into ancient light. But there is another anomaly at the edge of space, and that one is not a relic. It is not a mark from the distant past. It is happening right now, tonight, while you lie here. Whole rivers of galaxies are moving, all of them drifting the same way, toward a single point we cannot see, as though something beyond the horizon has been pulling on them since the beginning of time. Part 6. The Pull. In 2008, an astronomer named Alexander Kashlinsky, working at NASA's Goddard Space Flight Center, was studying the motion of galaxy clusters, the largest bound structures in the universe, each one a swarm of hundreds or thousands of galaxies held together by gravity. He and his team used the wall of ancient light as a kind of fixed backdrop, a still reference against which to measure how these enormous clusters drift. What they expected to find was randomness. Clusters scattered across the sky, each moving its own way, the small leftover jostlings of a universe settling into structure, pointing in no particular direction. Average them all together, and the motion should very nearly cancel out, a crowd milling in place. That is not what they found. The clusters were moving together. Hundreds of them, spread across enormous stretches of the sky, were drifting in the same direction, in a coherent stream, all of them flowing toward a single patch of sky in the southern heavens, a region about 20 degrees across lying between the constellations Centaurus and Vela. And they were not drifting slowly. The bulk of this motion clocked in at something on the order of 2 million miles per hour, a current of galaxy clusters streaming the same way at once, far too organized and far too fast to be the random settling the models predicted. Kashlinsky gave it a name in the same family as the cosmos's other great unknowns, the ones we have measured but cannot explain. There is dark matter, the unseen mass that holds galaxies together. There is dark energy, the unknown push driving space apart. And now there was this, a coherent streaming of clusters toward a single point, with no visible cause. He called it dark flow. Here's what makes it press on the mind in the quiet. The motion cannot be explained by anything we can see. Within the observable universe, within that 93 billion light-year sphere, there is no arrangement of matter large enough or close enough to be pulling all those clusters in the same direction at that speed. The galaxies and clusters and great walls of structure we can map simply do not add up to a force like this. And so the team was led to a conclusion that they offered carefully, knowing how it would sound. The pull must be coming from outside, from beyond the horizon, from something so massive and so distant that it lies past the edge of everything we can ever observe, reaching across the boundary with its gravity and tugging our part of the universe toward it. Think about what that would mean. We have spent this whole night establishing that the edge of space is a horizon, that we cannot see past it, that whatever lies beyond is sealed away from us by the speed of light and the age of time. Dark flow, if it is real, would be the first time we ever felt the other side, not saw it, felt it. A gravitational hand reaching in from past the wall, betraying the presence of something vast out there in the unseeable dark, something that was perhaps flung far beyond our horizon by inflation in the first instant, a structure or a concentration of matter so enormous that even from past the edge of the observable universe, its pull still moves whole rivers of galaxies, including, in the faintest way, the one you live in. When the team gathered more data in the years that followed, Kashlinsky reported that the flow seemed to reach even deeper than they first thought, extending across billions of light years and still pointing the same way, still streaming toward the same patch of southern sky, as steady and as stubborn as something that has been pulling since the beginning of time. To him, the persistence of it only strengthened the case. A pull that pointed everywhere the same direction and did not fade with distance, looked less like an error and more like a current with a source on the far side of the edge. And once again, in the dark, I owe you the honest part, because dark flow is the most contested idea we have touched tonight, more disputed even than the bruise. Many cosmologists do not believe it is there at all. When other teams analysed newer and sharper maps of the ancient light, several of them found no convincing sign of the flow, and argued that the original signal was the kind of false pattern that can creep in from the difficulty of separating the faint motion of distant clusters from the noise of the measurement itself. The effect sits right at the ragged edge of what our instruments can detect, and at that edge, it is fearfully easy to see a shape in the static that is not really there. The standard picture of cosmology, the one that has passed test after test, does not predict a dark flow, and most who study the question today suspect it will fade as the data improves, dissolving back into the randomness it was supposed to be. And yet we are not strangers to being pulled. Long before anyone whispered the words dark flow, astronomers had already noticed something that should have been impossible to miss and somehow was. Our own galaxy is not sitting still. The whole Milky Way, with the Sun and the Earth and you inside it, is racing through space at well over 1 million miles an hour. And not in some random direction. Not as part of the ordinary expansion that carries everything apart. We are being drawn. Measured against the still backdrop of the ancient light, our entire galaxy and the small crowd of galaxies it travels with are falling steadily toward a particular region of the southern sphere. They gave the thing doing the drawing a fittingly heavy name, the Great Attractor. Something out there a couple 100 million light years away, with the gravitational weight of tens of thousands of galaxies, reaching across that distance to pull our corner of the cosmos toward it. And for decades this was one of the most frustrating mysteries in astronomy, not because the pull was hard to feel, but because the source was almost impossible to see. The Great Attractor lies behind the worst obstacle imaginable. It sits behind us. Behind the dense, blazing disk of our own galaxy, the thick band of stars and gas and dust that stretches across the night, so crowded and so bright that it blots out almost everything beyond it. Astronomers call that blinded stretch of sky the zone of avoidance, because for so long they simply had to avoid it, unable to see through the glare of home. The thing pulling the Milky Way was hidden, cruelly behind the Milky Way itself. Slowly, patiently, they found ways around the blindfold. Eyes that see in infrared and X-ray can pierce the dust where ordinary telescopes fail, and one careful survey at a time, the hidden country behind the galactic band came into focus. There was a great cluster there, the Norma cluster, a real and massive thing crouched in the zone of avoidance. And beyond it, farther out, an even greater weight came into view, the Shapley supercluster, the single largest concentration of galaxies anywhere in our cosmic neighbourhood, an immense gravitational anchor toward which a whole watershed of galaxies, our own among them, appears to be flowing. We are, it turns out, part of a vast current of galaxies, a structure so large it was given its own name, mapped only in recent years by tracing the flow lines of thousands of galaxies the way you might map a landscape by watching which way the rivers run. It turned out that our Milky Way sits within an enormous watershed of galaxies, all of them slowly draining the same direction, like rain finding its way down into a single great valley. They called it Laniakea, a Hawaiian word meaning immense heaven, and it spans some 500 million light years and holds on the order of 100,000 galaxies. We had thought of our galaxy as belonging to a small local group, a quiet cluster in the dark. Instead, we learned we are one droplet in a flow vaster than anything we had pictured, a whole continent of galaxies leaning together toward that distant, hidden mass. And here is the detail that lifts the hair on the arm in the quiet. The direction of the Great Attractor, the way our galaxy is genuinely measurably falling, lies close to the same patch of southern sky that the disputed dark flow points toward. The same broad corner of the heavens near the constellation Centaurus, implicated twice. Once by a pull we can explain and once by a pull we cannot. It may be nothing. It may be pure coincidence that two mysteries about cosmic motion happen to gesture at the same region. The two are wildly different in scale, after all. The Great Attractor and the Shapley supercluster sit comfortably inside our observable universe, a few 100 million light-years off, made of ordinary visible galaxies, obeying the ordinary rules of gravity. They are the reassuring kind of mystery, the kind we solved by building better eyes. Dark flow, if it is real at all, claims something far stranger, a pull from billions of light-years away, from past the very edge, from a mass we will never see, no matter how clever our instruments become. But the resonance is hard to shake. Stand in the dark and feel it for a moment. Our galaxy is falling towards something we spent decades unable to see, hidden behind the light of our own home, and out past the edge, in roughly the same direction, some scientists believe a deeper current may be flowing towards something we are forbidden ever to see at all. The Great Attractor is the part of the story with an answer. It is the pull we chased down and named, and it sits right next to the part of the story that has no answer, the pull that may reach in from beyond the horizon, as if the universe was showing us the solved version and the unsolvable version side by side, in the same patch of sky, daring us to tell where one ends and the other begins. So we hold this one too with open hands. It may be a doorway, the one place where the universe beyond the edge made itself felt inside our own, or it may be a ghost in the machine, a pattern the mind and the instrument conjured together out of noise, destined to vanish under closer looking. We do not yet know, but somewhere in the southern sky tonight, between Centaurus and Vela, there is a direction that some of the clusters of galaxies may, just possibly, be quietly leaning toward, for reasons that lie forever out of sight. And if they are, then the edge of space is not only a place we cannot see past, it is a place that can reach back. Part 7. The Last Edge. We have walked a long way out tonight. We started at the shoreline of seeing, the horizon that belongs to each of us, and we found it was not a wall but a limit of light. We reached the wall of fire, the oldest glow there is, cooled to a whisper and falling on you in the dark. We learned that the universe is flat, and that flatness may mean it never ends, that it repeats you endlessly across an infinite distance. We followed inflation out into an ocean of bubbles, universes without number, sealed away forever. We stood before the cold bruise that might be the touch of another world. We felt the dark pull that might be a hand from beyond the horizon. And in every case, the deepest answers slipped just past the edge of what we can ever confirm, leaving us with the most human thing of all, a question held open in the dark. But there is one more edge, and it is not made of distance. It is made of time, and unlike all the others, it is coming for us. It is the only edge on this whole journey that we are certain of, and the only one we cannot point a telescope at because it lies in the future. You will remember far back at the beginning that the observable universe has been growing, that its edge creeps outward by about a light year every year as the light from ever more distant places finally arrives. That is true, and it is gentle, and it makes the cosmos feel like something slowly opening. But there is a second motion working against it, and in the long run the second motion wins. Space is not just expanding, its expansion is speeding up. Driven by that unexplained dark energy woven into the emptiness, the most abundant ingredient in the cosmos, every region of space is pushing every other region away faster and faster as time goes on. For now, this is slow and far off, no threat to anything you love. But carry it forward, far forward, across spans of time that dwarf the age of the universe so far. As the expansion accelerates, the distant galaxies are carried away from us faster and faster, their lights stretched redder and dimmer, until one by one they cross a threshold beyond which their light can never again reach us. They do not explode, they do not vanish in fire, they simply recede past the edge, slipping over our horizon like ships going down beyond the curve of the sea, their last light reaching us stretched into faint and fainter red, and then gone. The observable universe, which grew so patiently outward, will in the deep future begin to empty. The 2 trillion galaxies will leave, not by moving away through space alone, but by space itself, unspooling between us, until the gulf is too wide for any light to cross. In that far future, a watcher on some distant world will look up into a sky that has gone dark and small. The other galaxies will have receded past their horizon and disappeared. Only their own galaxy will remain, an island of light in a black and silent ocean, with no evidence anywhere in the sky that anything else ever existed. The edge of space, which for us is a vast bright sphere full of 2 trillion galaxies, will for them have closed in until it holds almost nothing at all. The horizon will have become a wall after all, and the wall will be made of emptiness. There is one idea, stranger than all the rest, that I will leave at the door without walking through, because no one can yet say if it is true. Some physicists, working at the deepest level of the theory, have found hints that the universe may be holographic, that all the richness inside any region of space, every star and every particle and every one of us, could be fully described by information written on the boundary of that region, on its distant edge, the way a flat surface can store a 3-dimensional image. And if that is so, then perhaps the most unsettling possibility of all is that the edge is not the faraway thing and we are not the real thing. Perhaps the boundary is what is fundamental, and everything within it, including you, lying here, breathing slowly in the dark, is the projection, the image cast inward from the edge of space. We do not know. It may be the truest thing anyone has ever guessed, or a beautiful mistake. It rests out there with all the others, past the limit of what we can prove. So what is hiding at the edge of space? After all of it, the honest answer is that we have stood at the boundary of human knowledge tonight and looked over, and what we have found is not a single thing but a whole quiet country of maybes. Maybe nothing but more of the same, galaxies without end, you repeated in the dark forever. Maybe an ocean of other universes, sealed away. Maybe a bruise from the one-time something pressed in. Maybe a vast unseen mass, pulling. Maybe a boundary on which our whole reality is written. The edge of space is not a place we have failed to reach. It is the exact place where our seeing ends and our wondering begins. And that line, that shoreline, may be the most important thing about us. Because remember the very first thing we said. The edge belongs to the observer. It is your horizon. And remember the gentlest thing we said, the thing worth carrying down into sleep. To something out there, across all that dark, past every theory we have walked through, you are the edge.